let me show you what I believe is the best way to build apps right now. So I'm going to show you the high level overview. I'm also going to be diving a bit into the code, and I will be sharing my reasoning behind making some of the choices. So before we dive in, so who is this for? So for context, I help app founders reach financial freedom through building an app portfolio. And for that, like pretty much the first question is, okay, how do I build apps? So I made this architecture, and this is to help you go from 0 to 1 to build that app, and it's definitely pre-product market fit. So while your app business is at the biggest risk, so we need to answer the question, does anyone want my thing or not, as soon as possible. So that's who it's for. And then what are some of the goals? So we need to get the product market fit the fastest. So that means fast development. We want to be launching to all of the platforms if possible. So that's Android, iOS, web, and even desktop if that makes sense for your apps. And we also want to have fun while doing it. So you'll see like Flutter and Firebase is such a fun tech stack, and I still enjoy it like after even after like years of using it. And then we're gonna also focus like on simplicity. So people like adding, complexity to the tech stack, to the code, the architecture, the everything, and then I don't think that's the right way to do things. So this architecture is quite simple, and our focus is, just driving results. So building the app fast, then launching, and then eventually getting to that product market fit and becoming financially free as an app founder. So okay, let's get into it. On the front end, we will be using Flutter, and on the back end, we will be using Firebase. So let's start there. So why Flutter? It is just aligned with our goals, right? So development is crazy fast. It has everything that you need. So material design is already included inside. You don't need to care about design too much. And it has like you don't need to care about the changes in the native app system basically. So Flutter is a layer like above the native layer, and that means like it doesn't matter about if operating system changes, if there are Android updates, iOS updates, Flutter will just continue to work, and it will look the same on all platforms. So it's just amazing. So that's one thing. And then okay, why not maybe like React Native or some similar like cross-platform stack? Well, I mean, simple. Flutter is just like it's giant and it's continuing to grow. It's Google's child, and Android is also Google's, and Firebase and like Android Studio. So everything just works fine, right? Um, it's why people like pick for hardware pick Apple, right? They have the MacBook and the iPhone and the iPad and everything. I mean, everything just works amazing, right? So that's that. And on the back end, why Firebase? Again, we need to focus on what are our goals, right? We need to be fast. It needs to be for multi-platform. It needs to be simple, and we need to be driving results. So anything that it's not like just one tool is just not good for our goals. So I see people, having like five different things on the back end. There's like standalone Python, then there's like some crazy thing on the AWS, and then there are, a few other like services or whatever. I mean, why complicate? So you are pre-product market fit, and that means like your business is at risk. And if you are like focusing on the wrong stuff, I mean, you're just gonna die, in the business sense, of course. So yeah, that's it. And like Firebase has everything that we're gonna discuss it, and it's free to start, cheap to scale, and like my top app, 170K users never crossed like $10 in cost, so per month. So it's just amazing. So okay, let's go to the front end. So for state management, we will be using Block. I get this question a lot, like what do I use for state management and why Block? Why not like GetX or some other popular plugins for Flutter state management? And the reason is simple, like those other plugins are too forgiving. So they let you like access state anywhere, change state anywhere, do anything anywhere, which seems good, but it's actually very like prone to errors and not even just like bugs that are like the app was not working, but actual like architectural level issues where your code, as it grows, it becomes this like complexity monster, and it's like a spaghetti code as they call it, and then like it gets just so hard to like scale and maintain, and we don't want that. So Flutter block is very like strict, and you can access block only if you have the context, and then the stricter the rules, the harder it is to make a mistake. So, okay, that's state management. And then we will have four layers. So let's discuss them. There's UI, which is basically Flutter widgets. Then there's block, which stands for business logic, but it's also the name of the plugin that we will be using for this layer. And then the blocks will have its own state. So all of the like business states should be held inside of the state and not in the block class, but I'll show you this later on in the video. Then we have the repository, which is high-level API. So for example, like get user or set lesson finished or things like that, high-level API. And then there's the provider layer, which is the bottom one, and that's the low-level API. So that's basically calling your Firestore, calling, making backend calls, making calls maybe to local storage or anything else that's basically low-level implementation, HTTP calls, things like that. And these layers, okay, there are four, and like the layer only communicates with the one below. So UI only communicates with block, block only with repository, and repository only with provider. And the reason is simple. We want to separate like who's in charge of what and who needs to keep track of what. So as a concrete example, UI should not care what's our low level like database implementation. It doesn't matter from the UI perspective. Are we using AWS? Are we using Firestore or whatever? UI just wants like the user model and to show like user.name, and that's it. Like UI should not care where that user came from. And then, if we like decide to change our providers, change how we, manage state, manage like the low level stuff, UI will not be affected by it. And that effectively means we are developing and maintaining faster compared to like if UI knows the implementation details, then you need to change the UI as well if you are like changing the providers. So that's that. And then what about tests? So like honestly, early on, I just wouldn't worry about them. So your goal is to get to product market fit, and your app will be changing a lot. And you don't want to be stuck in that like hamster wheel of just like maintaining tests and changing them as the like business goals change. So best to focus on tests after reaching product market fit and after you are sure that the market wants your app. So yeah, I would just like honestly ignore starting out. Then okay, Firebase. So it has everything that you need, and let me maybe just show you in the console. So by the way, for this like example, the Firebase console and the code that I'm going to show you, I will be using my scalable Flutter app template. So I used to sell this actually, but I don't sell it anymore. It's just like available for all the clients that I work with, but it's not available for purchase anymore. Just so you know. And then, okay, let me show you a few of the things that Firebase offers. So there's authentication, which allows you for like a lot of different providers. So email, phone, anonymous, Google, Facebook, all the common stuff. So you have, authentication pretty much solved. Then we go into Cloud Firestore. So this is the NoSQL database. And let me explain you a bit what my thought process when like architecturing the data model for the database. So it's NoSQL, which means we can like write whatever. But let's try and add some like rules to make this a bit more meaningful. So from my experience, you shouldn't be using sub collections. It just creates complexity that's not needed. If you want a certain, and everything should just be like a top level collection. And then what happens if you want to like have connections between different documents or collections? Well, very simple. So let's say article needs to have like a user that created it. So then in the article, we can just have like user ID and have its value there. And with that, we can filter all the articles that a specific user created, and we can allow only that user to make edits to the article and no one else basically. So that's one way to do it. And then what if like the articles have let's say comments? Then we can create a collection called comments that would have a article ID inside of it, and maybe also like the author ID as well, which would be the ID of the user. So that way everything is top level. You have the reference to the other document if you need it. And it's just very simple to start. It's easily scalable because it doesn't add like any sub collections and complexity like that. And you can always make changes on the fly. Um, so that's database. And by the way, Firestore database is like the new cool thing that you should be using. Real-time database is a bit older and has a very like specific use case that, yeah, it's not for this video. So okay, then we go into storage, which is basically like a file storage, so you can upload whatever images, videos, audio, any binary. Um, then there's hosting, so you can use it to host your app, and you can use it to host your landing page as well. So in one Firebase project, you can have, Android app, iOS app, web app, and also landing page if that's what you want. And you can use hosting for like both the web app and the landing page. So those are like two different things, and yeah, you can host both. Then there's cloud functions. I'm gonna dive a bit deeper into them when we get to the code part. But those are basically, where we will be writing our like business logic of, adding things, editing things, and like that. Then there's remote config, which is basically feature flagging on the server side. It's a bit more advanced than that, but you can think of it just like feature flagging, and then you can add complexity if you'd like. Then there's Crashlytics, which is really good for figuring out what's going on in production. So is the app fine? Is the app crashing on Android, on iOS? What's going on? And you will be receiving emails if things go wrong. So if there are certain crashes repeating, so you don't need to like check it like every day. You will receive an email. Then there's analytics and events. So Firebase uses Google Analytics actually, and it's like pretty sophisticated with the data that it can provide to you, and you can log your own events, or you can just like track usage in terms of daily active users, monthly active users, type of device, average session duration, and so on. Then there's messaging, which is basically notifications. Dynamic links that's deprecated, and I think that's like the basics that you should know about Firebase. As you say, that there's like so much more, but yeah, we just don't have time to go over everything. So okay, that was high level. So let me now walk you through some of the code. So again, this is from my template that's available to the clients. I don't like yeah, it's not available anymore as a standalone. So okay, let me show you first the four layers. So what I like to do is wrap my app widget, which is like material app widget, inside of this dependency injection widget that I create, and then I wrap that with like providers, repositories, and blocks that are top level. So for providers, I just keep all of them top level because repositories need to access them. So this is just like the easiest way. Just all the providers that you have, you can have them like this with the multi-repository provider. Then we go into the repositories. So as you can see, like the repositories have dependency to the providers, right? All of these are providers. So then we created the repositories here, and they can access the providers. And repositories, we also want all of them to be top level so that any block that needs a repository can access it from yeah, just from the context past. I'm going to show you how. And then we go into blocks. So I actually prefer qubits. They're simpler, and development is just faster with them. And as you can see, qubits or like the block layer is dependent on the repository layer. So there shouldn't be any like providers here that are dependencies for qubits or blocks, just repository. And these are all top level qubits. So let's think about it. So should your blocks and qubits be accessible from anywhere or just on certain screens? So for global things such as user, we want them anywhere, everywhere, right? Like user, we just need to access the user throughout the app. So it makes sense for the user qubit to be a top level qubit and accessible anywhere. Same goes with some other things, maybe such as like notifications and so on. But for some other stuff, such as add article qubit, for example, the qubit that we use to add an article, it doesn't make sense that that one is top level, right? We just need it in the screen where we are creating the article and nowhere else. And that means, we should just instantiate it there. So I can show you an example maybe. Okay, there's here an example of, in the authentication route, we just need like the auth qubit there. And as you can see, like before returning the auth page, we wrap that in the qubit so that the qubit is accessible from this page, but not accessible anywhere else. And that's the strategy that we should be using. So we should try and be as strict as possible so that it's like impossible to make a mistake, right? We don't need to like log in from a certain like screen that's not authentication flow, right? And with this approach, it becomes impossible to do that because if you try and access auth qubit, you will just get a like an exception while development. So it's again, yeah, not possible to make a mistake, which is what we want. And again, if you compare that to like any globally accessible state plugins that are out there, you just cannot make a rule like that easily as you can with block. So okay, that's that, and then maybe in the auth page. So how do we access that? We can use listeners, block listener, and then do things on state change, or we can do. Let me show you how I created a like extensions for users. So for example, I created an extension watch current user that watches the qubit and returns, null if not ready, and returns the user if ready. So you can like watch directly, or you can create extension methods like this to help you um, get the state. So you can get the state from like just reading the qubit, or you can watch the state with the watch. So that's one thing. And then how do qubits and blocks look? So the main class should be stateless, meaning that there shouldn't be any like variables here that can change. So the repositories and other dependencies should be final, and there should be like no state here because all the state goes into the state class of the block or qubit. And then, okay, there are always exceptions, right? So there's the stream subscription that we are using here that does change. But it's just so that we need to listen to the user stream, and then like once this qubit closes, we need to cancel that subscription. So that's why we keep this as a variable. It's not really like a user's state, right? It has nothing to do with the user, but it's just that we are creating a stream here, and we want to make sure that it's disposed. So it's not really a user state, right? It's some kind of just like an internal state that we happen to need. And this is like an exception case. It's not really what you should be having like most of the time. Most of the time, it should be just like final uh, repositories and nothing else. And then how do I structure the folders? There's core with a lot of like the common stuff, and then there's feature with all the feature folders. So for example, in the user, we have all the layers. So there's UI, block, repository, provider, and there's also model, of course, which is the plain class, for the user model. And yeah, that's it. I don't want to go too deep into it. So yeah, this is the basics of Flutter app architecture. So now let's get into the Firebase side. So yeah, let's see. Let's go into the index. And okay, this is how I structure my index file for Firebase projects. So okay, these are imports, not that important. Initialize app, and then I create every function as an export here, and basically just separate it through these comments that are like features. Okay, this is for the user, functions for user, functions for articles, functions for feedback, and so on. And these are HTTP callable functions, and I prefer them over like HTTP requests. Then you need to do like parsing, things like that, and then you don't always have the user that's getting authenticated. So yeah, it's just easier to use these on-call functions. And then these are just like implementations. So let's see one of the functions. This is like the most common function I use. I use it for every project on user created. And let me walk you through the reasoning, like what's happening here. So when a Firebase authentication user like authenticates, so through like Google sign in, Apple sign in, email, whatever, it creates a new user record. And if we don't do anything about it, then we don't have like a user document inside of the Firestore. So we have a like authentication user, but we don't have a Firestore document user. And what this means, like to be like very clear, if we go into authentication, you can see the users here, but they don't get like their like document created automatically, which is this like this document. We need to do that ourselves, and for that I've created a function. So basically this gets triggered when authentication user is created, and then I just pack that into a user object, and I write that to the collection of users. And for the document ID, I use the user ID from the user record, which is the Firebase authentication ID. And with that, um, these IDs are like the same. So if we go back to authentication and pick one, let's say this one, copy user ID, and then go to the database and then search, we will see that the ID of the document is the same of the ID of the authentication user. So it's a really nice way to keep things concise. So okay, that's Cloud Functions. Then let's get into rules. So there's storage rules and Firestore rules. And you should be using that to make the access as strict as possible and not allow anything bad to happen, basically. So, for example, users can read their own like uploaded files only if they are signed in, and they can write only if it's them and the file is like not larger than 5 MB. So this is just like one example, and you can expand the rules however you like. And then on the Firestore side, similar structure. So for example, articles could be read by anyone, and users can read their own data only, and no one else can read their data, right? So allow get only if I'm signed in as this user that's trying to read the data. So that's it. That's the architecture and a bit of the code examples as well. So yeah, that's it. That's it for this video. And what I want you to do, so if you enjoyed it, give it a like, and also leave a comment if if you want me to expand on anything that I've touched. If you have more questions, if you want me to dive deeper. And if you enjoy these videos, then subscribe because I will be releasing one video per week. So that's it. Thanks.